Welcome back. In this lesson, we're going to be looking at the syllabus point A1.1.5, describe the fetch, decode, and execute cycle. The fetch, decode, execute cycle is the fundamental cycle of instruction execution inside a computer. This cycle is also known as the instruction cycle. When you run a program, it is executed by your CPU. The fetch, decode, execute cycle describes how instructions are executed step by step. It consists of three main steps. Fetch, the CPU fetches an instruction from memory. Decode, the CPU decodes the instruction, which means it interprets the instruction into a set of low-level operations that the CPU can execute. And finally, execute, where the CPU executes the instruction, which means it carries out the low-level operations that were specified in the decoded instruction. This cycle is repeated for each instruction in a program, and the speed of the CPU is largely determined by how quickly and efficiently it can execute this cycle. Okay, let's look at the fetch, decode, execute cycle in a bit more depth. In the fetch phase, the CPU retrieves a machine language instruction from main memory, which is typically RAM. This involves the CPU sending a request to the memory to fetch the instruction, and for that, it needs the address of that memory location. So what exactly happens in the fetch cycle? Well, the program counter holds the memory address of the next instruction. This address is sent to the memory address register, MAR. The instruction is then retrieved from RAM and moved into the memory data register, MDR. It is then transferred to the instruction register, and then finally the PC or the program counter is incremented to point to the next instruction, and this cycle continues all the time. In the decode phase, the CPU interprets the machine language instruction which was fetched during the previous phase. And this phase is managed primarily by the CPU's control unit. And it decodes the instruction by analyzing the various components, like the operation code, the opcode, that dictates the type of operation it is, like add, subtract, and so on. The operands are the data that needs to be operated on. For example, if you did add 1 and 2, the operands are 1 and 2. And then finally, you've got addressing modes, which determine how to locate the operands where they're stored. Additionally, the decode phase involves checking the validity of the instruction and ensuring that the operands are within an acceptable range. And finally, you've got the execute phase. And during the execute phase, the CPU performs the operation which was just decoded in the previous phase. The specific operation is then carried out, and common commands include arithmetic operations like addition, subtraction, multiplication, division, or the logical operations like AND or NOT. And these are typically performed by the ALU. They can also be loading operations and storing operations. These are called memory access operations. And finally, there could be control operations, which are like conditional and unconditional jumps. Basically, think of these as your if statements. The results are finally stored in registers, or they can be sent back to RAM. This cycle repeats continuously while the CPU is running. Now let's look at the role of address buses and registers in this process. Now, the interaction between memory and registers is crucial to the fetch, decode, execute cycle. Communication between the CPU and memory during the cycle relies on three key buses. The address bus, which carries the memory address from PC to MAR and then from MAR to the RAM. The data bus, which transfers actual data between the CPU and memory, example from the RAM to the MDR, that's where the data bus is used. And the control bus, which sends control signals like reading or writing, clock or interrupt signals, that is used between the control unit and all the other components. So the MAR interfaces directly with the address bus, the MDR receives data via the data bus, and the control unit sends read or write signals via the control bus. Now, in addition to read and write signals, it can also send other signals like acknowledgement signals, for example, that a data transfer has been completed. Interrupts could be possible, timing signals could be possible. So it's not just read or writes only. The role of the registers is to simply store the data or the addresses that are necessary for the fetch, decode, and execute cycle. Okay, let's look at a worked example. The instruction add n1, n2, n3 adds the values in registers n1 and n2 and stores the results in register n3. Describe the fetch, decode, and execute phases of an add instruction cycle in a CPU. Now, for this type of question, you would have to write in a description form what actually happens. So let's look at a typical answer. In the fetch phase, the PC or the program counter points to the address where the instruction is stored in RAM. The address is copied into the MAR and then sent to RAM via the address bus. The control unit sends a read signal via the control bus. The instruction add N1, N2, N3 is transferred to the memory data register via the data bus, and then copied into the instruction register. In the decode phase, the CU then reads the instruction from the IR, decodes it using an instruction set, and identifies the operands N1 and N2 along with the destination register N3 where it needs to store the answer. In the execute phase, the ALU receives the operand values N1 and N2, performs an addition, and stores the results in the register N3. Now, this would be a typical answer. You will need to think about the context that you're given in the exam. Another type of question that you'll get is something like the one you see on screen, where you got a bunch of addresses and some data and instructions. Now, in this particular table, addresses 1003 and 1004 store data values, because that's fairly obvious, 50 and 70. Address 1000 contains a load instruction to load data from address 1003, which is 50. Address 1001 has an add instruction to add the contents of addresses 1003 and 1004, which results in 120. And finally, address 1002 includes a store instruction to store the result from address 1001, which is 120, into address 1000. That means you overwrite 1000, the LDA instruction is overwritten by 120 because the answer is stored there. Now, these are typical questions that you might get in an exam, which shows your understanding of not only how to describe the fetch, decode, execute cycle, but also to implement it. Now on screen you see a few key terms related to this lesson. Make sure you do pause the video and go through them. You should be able to define these key terms. They tend to be a single mark question in the exam from time to time. Please add them to your glossary. That's all for this particular lesson. You should be able to answer the following questions. What is the first step in the instruction cycle and which register is involved? What role does the control unit play in the decode phase? What is the function of the memory address register in the fetch, decode, execute cycle? Describe the use of buses and the registers involved. What happens during the execute phase of a load instruction, and so on. If you do have any questions regarding the content of this lesson, please get back to me in the comments. Otherwise, I'll see you in the next one.